Hello there, amazing people, students, and all the lovers of chemistry out there. I'm super excited to be here with you once again on yet another episode in this series where we're learning how to balance chemical equations. And on today's episode, we're looking at the law of conservation of mass. So without any further ado, let's get into what we have for today's video. First of all, let's define the concept of what this law is all about. The law of conservation of mass. What is it and what is it all about? In chemistry, the law of the conservation of mass simply says matter is anything that has mass and occupies space, by the way. So matter cannot be created or destroyed in a chemical reaction. What this simply means is when you have a chemical reaction taking place, whatever you started with is going to be equal to whatever you're going to end with. No new substances will be magically created or disappearing from the chemical reaction. So what this means is this: the number of atoms you begin or start with must be exactly the same as the number that you end with. So if you started a chemical reaction, for example, with let's say 100 atoms, it means you must end that same reaction with 100 atoms. No single atom will be created and no single atom will be destroyed. However, they can change from one state of matter to the other. We're going to get to that point very soon, okay? But for now, just know that during a chemical reaction, matter is not created nor destroyed. The second implication of the law of the conservation of mass is that atoms are rearranged. They are not removed or added out of thin air. For example, if I have a block of ice, okay, so let's say this is ice right now, and after exposing it to some heat, it changes into water. Now, this is let's assume this is a reaction that has occurred. Now, the amount of ice that I started with, or the weight of ice that I started with, according to the law of the conservation of mass, it must be the same with the amount of water that I am ending with. Okay, no new substances are magically disappearing, and no new substances are magically appearing from nowhere. That's what we mean. And then the second implication is that atoms are rearranged. They are not removed or added out of thin air. So what we mean is that the structure of ice has changed from solid to liquid. So that's what a chemical reaction is all about. The structure can change, but the number of atoms that you started with must be the same to the number of atoms that you end with. And then thirdly, the mass of the reactants must be equal to the mass of the products. Now, this is the simplest way I believe that you can break down the law of the conservation of mass. Okay, what the law of conservation of mass simply says or implies is that the mass of reactants is always equal to the mass of products. It's just like saying, for example, you begin a party with 10 people. At the end, you're supposed to end up with 10 people. No one should suddenly disappear or appear out of nowhere, except maybe they kidnapped a person. That's just by the way though. So you understand the concept of conservation of mass to mean that any amount of substance that you begin a chemical reaction with must be equal to the amount of substance that you end that reaction with. So now that we have that out of the way, let's check out a relatable example that can help you understand what we're talking about. So for instance, your mom gives you 2,000 naira. 2,000 naira for the week as your pocket money. Okay, so here you have it, 2,000 naira. And in the process of time, you spend some money, 500 naira on snacks, 800 naira on data, and then 700 naira on transport. Now let's do some math. If you add up everything you spent together, 500 plus 800 plus 700, everything is going to be equal to 2,000 naira. Do you know what just happened? You have just followed the law of conservation of money. What do we mean? It means that the amount you have must be equal to the amount you spend. You also understand with me that the amount that you spend is not possible for it to be greater than the amount that you have, except maybe you want to end up with debt. But you understand what I'm trying to say. So this concept actually drives home the understanding of the law of conservation of mass. The amount of money that you had was 2,000 naira, but the amount of money that you spent, when you add everything together, you saw that it has to be equal to that 2,000 naira, because money was not created or destroyed in the process. That is what the law of conservation of matter is all about. Now imagine if all your expenses, you now totaled everything and it became 2,500. You should be surprised and worried, because you only started with 2,000. How come you are ending with 2,500 naira? That would be nearly impossible. So in that same way, it is like that in chemistry. The total number of atoms on both sides of an equation must be the same and equal. Now here is what we mean. This is a chemical reaction on the screen right now. We have two elements, A and B, starting the chemical reaction. At the end of the reaction, you can see that we have the same elements, A and B, ending the chemical reaction, which tells us that what we started with is the same as what we ended with. That is what the law of the conservation of mass is all about. Now let's get into another concept in this lesson: visualizing mass in reactant. Now look at this simple reaction that we have on the screen right now. We have this reaction that shows the combination of hydrogen and oxygen to form water. Okay, so we have this reaction that shows the combination of hydrogen and oxygen to form water. Now you can see from the equation here, this equation is not balanced. How did we know that the equation is not balanced? First of all, let me rewrite it out. We have hydrogen, H2, combining with oxygen, O2, to form water, H2O. Now, if you check with me, you would see that on the left side of the equation, we have two atoms of hydrogen because of this number 2 over here. Okay, we have two atoms of hydrogen. On the right hand side, we also have two atoms of hydrogen. So hydrogen is equal on both sides. But for oxygen, you can see over here we have two atoms of oxygen. But on the left hand side, we have just one atom of oxygen, which tells us that oxygen is not balanced. So if you have two on the left hand side and you have one on the right hand side, it means the right hand side is lacking one more atom of oxygen. So what does that mean? This means that one oxygen atom is missing on the product side, and that is breaking the law of the conservation of mass. So in order to balance it, we introduced a coefficient of 2. I'm going to be showing you the process through which we balance chemical equations and introduce coefficients, okay? But this is now the balanced chemical equations. We have 2H2 plus O2 giving us 2H2O. Now if you check each atom or each element, you will see that it is balanced on both sides. For hydrogen, we have two atoms of hydrogen over here multiplied by this coefficient of 2. 2 times 2 gives us 4. On the right hand side, you can see two atoms of hydrogen over here with a coefficient of 2 as well. 2 multiplied by 2 gives us 4 as well. So hydrogen is balanced. Oxygen, you can see on the left hand side, two atoms of oxygen, and on the right hand side, this coefficient also affects this element of oxygen. So we have two atoms of oxygen on the right hand side as well. So both oxygen and hydrogen are balanced, and this has now followed the law of the conservation of mass. What we started with is now the same with what we are ending with. So at this point, here is a tip for you. Always remember that as far as the law of conservation of mass is concerned, what goes in must be equal to what comes out. We saw that in the equation that we just balanced for the combination of hydrogen and oxygen to form water. So when the equation was balanced, we added a coefficient of 2 on the right hand side. What was coming in from hydrogen was equal to what was coming out for hydrogen, and the same thing applied for oxygen as well. So the next thing to remember is that if you start with 6 atoms of high oxygen, you must end with 6. There are no cheating and no shortcuts as far as the law of conservation of mass is concerned. So here is a summary for all the points in this video. Matter or atoms is neither created nor destroyed during chemical reactions. Chemical equations must be balanced to follow this law. What law are we talking about? The law of the conservation of mass. Okay, so think about it like your weekly allowance. What you spend must equal what you got. So if you got 10,000 naira, for instance, you can't spend 20,000 naira because they will not be the same and balanced. So use this law as your guide every time you solve or balance an equation. So what we are saying in essence is, for every chemical equation you encounter, as far as the concept of science is concerned, what goes in must be equal to what comes out. So now that we have done thorough justice to the law of conservation of mass, the next thing to look at in this series will be the parts of a chemical equation. This is where we see things like the subscripts, the coefficients, the states of matter, and so many things that we'll be looking at in the next video. Up until then, my name is David, and all we do here is to take the mystery out of chemistry so you can make history. I'm eagerly anticipating your presence in the next video, so I'll see you there. Thank you.